Okay, let's look at this linear equation. This is a definitely linear equation. You can test that yourself. And I'm going to make the following changes below. So first off, I'm going to move this to the left-hand side as well as the 15. So we get minus 3/5 x plus 7 and plus 15 equals 0. And the 0 is the important bit here because I'm going to change the 0 to y. And what I've done here is I've created a relation by plugging in a second variable. When there's two variables, that's when you have a relation between two sets. Of course, if you simplify this whole thing down, you're going to end up getting this statement here. Now, it's very important, I'm stressing this again, it's very important to note that we specifically set y equal to 0. That's what gave us this relation. We didn't set y equal to 15 or something. Y equal to 0 is what we have. So if we were to look at this equation, not as an equation, but now as a relation and graph it, that means the original solution to this thing, this statement here, the actual solution x equal to something, is the same thing as the x-intercept. That's because when y equals 0, we have an x-intercept, and we specifically set y equal to 0. And so this gives us a geometric solution. And if we solve it either way, the geometric, finding the x-intercept, or solving the linear equation as we normally would by getting the variable by itself, we should get the exact same answer. So let's go ahead and solve this. Let's graph this guy. Okay, here's the graphed relation, and you can see we have a solution here at 0.65. That's what Desmos gives us as the x-intercept. And now the algebraic solution, well, if we subtract 67 over 5, now all we need to do is to multiply by 5 over negative 103. That cancels everything on the right, leaving just x. On the left, sorry, the other way around, on the right, we have the 5's canceling, and we get the negatives cancel as well. We get 67 over 103. And this is actually approximately equal to 0.650485, and it continues on. There will be a repetition here. I believe it repeats. I'm not sure where it repeats. This, of course, is a rational number, so we know it repeats indefinitely, or it terminates at some point. So it looks like it repeats indefinitely here. But you can see that we got almost the same solution. The reason why Desmos gave us 0.65 is because they only ever round to 3 places, and rounding to 3 places gives us 0.650. So this technique is very useful when you have numbers that are, you're fine with it being rounded, or it gives you whole numbers or numbers that, are no more than 3 places. This technique is very useful for checking your answer as well. But if you need an exact answer, that's when the algebraic solution is really what you need to solve for, because sometimes it will be just as as good as an approximation. So just keep that in mind. What this does show you is that the x-intercept for the graph is the same as the solution to the algebraic equation. That's the connection between algebra and geometry. The term 0 is also used to designate this quantity because the equation is 0 there. The y value is 0. So this is what's called a 0 of this equation. It's the x-intercept. It's also a 0 of the algebraic equation. That's what when we solved plugging in equal to 0. So that's the reason why 0 is also used to describe this situation. Go ahead and give it a try in number 9.